Hello friends and welcome to my channel. In this short video I will present you this DIY power supply. Was made in Germany more than 40 years ago. Let's begin. First of all, I have to tell you that this is very heavy. It has more than 20 kilos. And you will see why in the pictures. And this power supply, it's practically indestructible because it has inside only two powerful transformers. Let's see. Now you can see what this has inside. I think this is DIY, but as you can see, it's very well made. It's perfectly well made, as it is industrial made. It has two parts. This, the right part, it's a separation transformer. The mains voltage goes here, and on this socket we have output the voltage of the main power supply, but it's isolated for the live of the main power supply. This left part, it's this powerful transformer, and this powerful transformer has multiple outputs, as you can see here. As you can see, here is the common output, and these are 2 volts, 6 volts, 8 volts, 10, 12, and the maximum voltage is 24 volts AC. I measured the secondary part of this transformer, and it's 2.2 millimeters. That means that this output can give us up to 12 amps AC. Now here it's the alternative connection input, and this it's the continuous voltage output. These 4 wires are connected to a rectifier bridge, and here we have a rectifier capacitor, but I think that it's too old and needs to be changed. Now let's talk about power consumption. As you can see here, I hope that you can see, this is the separation transformer part, and without load it takes 31 watts of power consumption. This power supply without load, it takes 27 watts power consumption. I forgot to tell you that this separation transformer can take up to 5-6 amps and can give us approximately 1 kilowatt of power consumption. Now let's make some tests with this. We'll use alternative current. Let's test this. As you can see, 212, it's the mains voltage. Now this is the common. And this is 3 volts, it should be 2 volts. This is 6 volts, it's good. 9 volts instead of 8 volts. Perhaps because this was made for 220 volts all the time, and now we have 230 volts on the mains power supply. Instead of 10 volts we have 12 volts, instead of 12 volts we have 15 volts, instead of 20 we have 22, and instead 24 we have 25 volts. Now let's test the continuous part. I will use this tool. What I don't like about this is that it doesn't have a voltage indicator and on and off power LED. So this is minus, this is plus. So we have to put here alternative voltage, and here we'll have continuous voltage. I had to put this capacitor on the output, so I don't need to connect this capacitor, which is very old and probably it's not good anymore. But all parts but I bet the old parts are better quality than the newer parts that are made now. And here we have alternative voltage. We have 3.5 volts. As you know, if we have here 10 volts alternative current, we should have 15 volts continuous current, as you know, when you rectify. Now let's continue. So we have 3.5, 7 volts, 10 volts, 15 volts. This should be good as a auto charger on this position. 18 volts, 28, and this should probably out of range. I have to tell you that I'm impressed by this tool, because now we don't made these powerful and strong tools like this. I bet that it was very expensive at this time and was a lot of work. As you can see, it's very good quality of the parts. The case is very strong and it's very well made, and as you can see, it's almost perfect. Please write a comment about what you think about these old school tools versus new tools that are made now in China. I hope that you like this video. Please like and subscribe. See you in my next video. Bye.